So this is the version of the lab for formation of the solar system. For students who are absent for this particular lab, please make sure to do all of the parts of the lab and then share your file with me so that you can get credit. So the purpose of this lab is to discuss formation of the solar system, to figure out how gravity affected the formation of the solar system, to explain how the temperature of the solar system and the abundance of the elements that were present impacted the formation of the planets, and to model how matter clumped together under the force of gravity to form the objects in our solar system. So, the engineering practices for the next generation science standards, which are RT and READY standards, we are developing and using models. We are analyzing and interpreting data. We are using mathematics and computational thinking, and we are constructing explanations for science. So there are 4 stations in this lab. You will be doing those 4 stations virtually. The first one is the science skills station, and here you will evaluate the relationship between the distance from the sun of a planet and that planet's temperature. You will determine the role of temperature and the abundance of the present elements in how that planet formed, and you will evaluate how temperature determined the composition of the planet and the abundance of the element in that planet. The second station is a narrative station. You will read a text and watch a video that talks about the formation of the solar system, and you will learn about the stages of the solar system's formation and the role of gravity in the formation of those objects. The assessment station is the third station. You answer questions about some of what we've learned about the formation of the solar system. And the fourth station is the problem solving station. At this one, you will make a model of the formation of the solar system in the form of a flip book. So we start with the pre-lab activity. You will need to read through the lab overview, which follows this slide, and create a journal entry, which there's also a slide for, that defines solar system, molecular cloud, protoplanetary disk, gravity, and radiance. After that, give me a 4 to 5 sentence summary about what you're going to do in the activity. So once you've read the narrative, you're going to enter your definitions and your summary here. So at the science skills station, you will tell me the relationship between the distance from the sun and the planet's temperature, and then make an inference about how temperature impacted solar system formation. If you do not remember what an inference is, it's taking the information that you have and making your best guess about what determined this particular characteristic, and then infer how the abundance of elements in our early solar system impacted the formation of the planets. So you have data on the next slide. I'll go ahead and go to that and come back. That tells you the planet's distance from the sun and the temperature at each distance. The distance is measured in astronomical units, and this is the average distance between the sun and Earth. We apply this to other planets based on Earth's distance from the sun. So it may be a fraction of that amount, or it may be a multiplicative of that amount. The temperature is based on the amount of solar irradiance that reaches that distance. So how much sunlight do we get at that distance? So here's your data table. You can always come back to this slide. So the first activity is to graph temperature versus distance from the sun and label the distance at which each planet is found and connect the points with a line. Then infer which planets are rocky and which are gas. So you're going to surround the points of the rocky planets with a circle and the gas planets with a triangle. And I actually have an example of this to show you. So when you complete your graph, you kind of have an idea of what it's going to look like. And notice some of my points are in circles and some of my points are in triangles, depending on if they were rocky planets or gaseous planets. Then you're going to describe the relationship between the distance from the sun and temperature. So these are the questions that you're answering. So tell me the answer to each question. You can save a copy of this and add your answers to it, or you can do this on paper and send it, bring it back with you, or send it to me in a doc. The second activity is to use a graph to answer more questions. So the graph is provided. You're going to use that to answer the questions on the next slide. If you need to come back to this slide at any time, you can do that. So these are your questions about that first station. The second station is the narrative station. You are going to watch a video and answer some questions. So the video is at this link. If you need to go out and open it in a separate link, you can, but I'm going to try to play it in here.
Our solar system is the region of space which falls within the gravitational influence of our sun. The solar system is thought to have begun forming about 5 billion years ago from a giant spinning cloud of gas and dust. The core of this cloud grew under the influence of gravity and became denser and hotter. As material fell towards the growing core, the cloud increased in speed and flattened into a giant spinning disk. Eventually, the increasing temperature generated enough energy to trigger nuclear fusion. This fusion marked the birth of our sun. The lighter gas was swept far out into the solar system, leaving heavier, rockier material and metallics with high melting points nearer the sun. Molten metal and dust particles stuck together to form clusters, which in turn stuck together to form rocks. Mutual gravity caused these rocks to come together, eventually to form planets. In the hot inner regions of the solar system, rocky planets with metal cores were formed. In the colder outer regions, things were different. Further from the sun, temperatures dropped. Water vapor condensed and turned to ice. This ice, combined with the vast amounts of gas blown away from the sun, meant there was a lot more material here than in the inner regions. As huge cores of ice and metal grew, the gases swept away at the sun's birth were attracted through gravity. When the accretion of most of the ice and gas was complete, We were left with the gas giants. The solar system as we know it is around 4.6 billion years old. It's looking pretty good for its age.
Okay, so now that we've seen the video, you're going to answer the questions about it. If you need to play it again, you're welcome to do that. Just go into the folder with the presentation and you can do that. So there are your questions. Following this, you're going to have a passage called Formation of the Solar System. It covers several slides. You're going to read that and answer the questions. So if you need a little help with reading, I'm going to read this for you. If you don't, you can skip ahead a little bit. Earth is part of a planetary system called the solar system. The solar system includes the sun, 8 planets, and many moons. The formation of the solar system began 4.6 billion years ago. There are 4 distinct stages in our solar system's formation. Number 1, our solar system formed from a cloud of gas and dust. This cloud was called a molecular cloud. The molecular cloud consisted mostly of hydrogen. Number 2, the molecular cloud rotated. Hydrogen clumped together at the center of the cloud to form a ball of hydrogen. As the ball became more massive, its gravity became stronger. Eventually, its gravity became so great that the gas collapsed to form the sun. Number 3, the remainder of the gas and dust in the molecular cloud formed a spinning, flattened disk around the sun. The disk is called a protoplanetary disk. The region of the disk closest to the sun was hottest. It was too hot for gases, but metals and rocky particles could orbit close to the sun. Gases orbited farther away from the sun. As the materials rotated, they began to clump together. They first formed small objects. These objects collided with each other to form larger objects. As they became larger, their gravities became stronger and they attracted more free material and objects to form primitive planets. Scientists believe it took 100,000 years for the collisions to form primitive planets. Number 4, most scientists think our primitive solar system had more than 8 planets. Some primitive planets collided and merged. Some collisions created the planets' moons. Eventually, only 8 planets were left orbiting the sun. Over time, they completely cleared their orbital paths of debris. As collisions became less common, the orbital paths stabilized. The stabilization of the orbits also caused the planets' environments to change and stabilize as well. Some of the debris from the formation of the planets is still found in the solar system. There is a collection of small objects that orbit the sun in the outermost regions of our solar system. This region, called the Kuiper Belt, most likely contains remnants from the solar system's formation. So use that information to answer the questions. You are welcome to go back and look at the narrative to get answers. Now we have the assessment station. You're going to answer the question on the slide, and there are 2 bonus questions that are not required to be answered. The final station is the problem-solving station, and you are going to make a flip book to animate what the formation of the solar system probably looked like. Just to make sure that we understand how our flip book should look, there is a short video showing how to do this. So make sure that you include in your flip book the molecular cloud, the formation of the sun, the formation of the protoplanetary disk, the motion of gas and dust around the sun, collisions that led to the formation of the 8 major planets, and then the clear orbital paths of the planets. Make sure you answer the questions. And then the last part of this lab is a synthesis project, which you will not finish today. And if you would like to wait until you can get together with your regular lab group, you can do that. You will need a total of 15 points for a complete project. And there is a list of combinations of 5, 10, and 15 points that you can choose from to decide what you want to do for your project. And you will want to get with your regular group to determine how you will earn all of the points. The due date for this, excuse me, will be February 11th. So that will give you about 2 weeks to do the synthesis project part. If you are going to be out beyond February 11th, let me know that so that I can figure out how to get your synthesis project for you. I may have to send you that in email and help you get some idea of what you want to do to complete the project. Once you are finished, do your post-lab reflection. So answer the questions, at least 2 of them, and write a 4 to 5 sentence summary about what you did in lab.